Hello and welcome to Home Science Lessons with Mr. Mac. Lesson 8, Power and Energy Transfers. So please put your phone out of the way or get rid of distractions or close any windows that are going to distract you at this moment. Get some pen and paper and probably a calculator today and get ready to give it your best shot. Try and do the whole session in one go. Remember, it's not just watching the video. You need to take some notes. You need to have a go at the slot activities as well. Right, here we go then, please. So I have a bit of retrieval practice. I've got some slides ready for you. There'll be some teacher instruction and modeling under the camera from me. And then we'll have a go at embedding and trying to memorize some of the knowledge. And then there'll be an opportunity to practice what you've learned near the end of the session. Slide 1 for retrieval practice, taken from Structures and Bonding, topic 2. Pause the video and have a go now. Okay, and there are the answers for those questions. Mark your answers. If you got any wrong, please do a little bit of revision on that section. Next slide. Physics, particle theory. Pause, have a go now, please. And here's the answers for this slide. Pause, mark your answers and jot down any weaknesses that you have. And final retrieval practice slide today is cell biology. Pause, have a go, please. And there are the answers, including a diagram of mitosis. Last time we did some slot questions on alternating and direct current, the answers of which appear in the table. And we also did some questions on wiring a plug, the live, neutral, and earth wire, and also some questions on the function of the earth wire in a plug in particular and how it protects the user from danger. So jot down your answers, mark your answers from last time, and any that you got wrong, fill in your corrections and have a go at drilling or embedding those answers. Okay, what about our new knowledge today? So our new knowledge is going to be about the equations for calculating power, work done, and a little bit of explanation on energy transfers. So get your pen and paper ready. And here we go. Right, so the two equations for power, what are they? And state the units for each component. So power is equal to potential difference multiplied by current. That's the first equation. Or we can write that as P equals V times I. Power is measured in watts. Voltage or potential difference is measured in volts. And current in amps. So that's one of the equations that you need to know. What's the other equation or main one? This one doesn't seem to come up as many times on past paper questions, but it's still one that you need to know. So power equals current squared times resistance. So the power is measured in watts. Current squared is measured in amps, or current measured in amps, and then we're going to square that. And resistance in ohms. So a little example for you here of a style of type of past paper question. A diode, and we know what one of those is from previous, they only allow current to flow easily in one direction. type of resistor. A diode has a resistance of 456 ohms. Current is 2.8 amps. What, pardon the pun, is the power? What is the power? So what we do, look at what we've been given. We've been given resistance, we've been given current, so it must be this equation here that we need to use. So let's write it out. P equals I squared times R. And probably what I should have done up here is write that equation form as well. So I'm going to write it underneath here. P equals I squared times R. Then we fill in the numbers that we've been given. So current is 2.8. Resistance is 456. So you need to times those by each other to get the power. But what do we have to do to 2.8? Well, actually, first of all, we have to multiply 2.8 by 2.8 and then multiply by 456. So if we get our trusty calculator, as always, use a calculator. 2.8 times 2.8 equals 7.84. So 7.84 times 456 times 456 gives us an answer of 3575 if we round it up. 3575 watts, or W for short. And that's a little example of how we can use P equals I squared R. So we've got a couple of other equations to look at today before we finish going through the new knowledge. And they both involve energy transferred or power. So energy transferred is equal to power times time. Important that power is measured in watts or sometimes kilowatts, and time is measured in seconds. We're going to stick with watts for today, and energy is measured in joules. So E equals P times T. Units, joules, power in watts, and time in seconds. Okay, little question for us after we go through our second equation. So our second equation is energy transferred equals charge flow times potential difference. So you might want to pause at this moment in time to write down your notes, and then we'll just go on to one more little worked example. And here it is. A hair dryer of power 150 watts is switched on and transfers 680 joules of energy. How long is it on for? switched on for. So we write down the equation that we're going to need. We've got energy, we've got power, and we need to find out time. So it's going to be this top equation by the looks of it. So E equals P times T. So 680 equals 150 times T. So in this case, we're going to have to rearrange our equation. So draw our lines. And if we want to get rid of this 150 just to leave T on its own, we need to divide this side of the equation by 150. But whatever we do to this side, we need to do to the other side also. So we need to divide both sides of the equation by 150. So 680 divided by 150 equals T. And as always, let's use our trusty calculator. 680 divided by 150 equals 4.53. And if we round that up to 4.5, so T equals 4.5 seconds. So there's a couple of little worked examples for you that should help you with the slop questions, which are coming up very soon. So pause the video, make any notes that you need to make, and get ready for the next stage. So how are we going to embed this knowledge? Well, to do that, we need to drill, drill, drill. Remember, drill is thrill. So how do we go about doing that? Well, a couple of ways about it. We can read over the notes that we just taken or just been given, cover them up, and then write what we can remember. That technique's known as look, cover, write, check. Or we can get someone at home to test us on it. So get someone to test you on those 4 equations, because those are equations that you're going to need to know in your final GCSE exam. You don't get given those generally, especially on higher tier. So have a go. Pause the video for about 10 minutes and have a go at really and drilling and embedding that knowledge. Okay, after you've done that, there is a slop task to complete, which is attached to Show My Homework, and it will also be present on the next couple of slides. So slide 1, there's slop 7. Have a look at that, pause it, or if you wish to, go on to Show My Homework and print off the paper version. I'm also going to attach the PowerPoint presentation to Show My Homework, so you could just print off the slide if you want to as well. So pause, have a go, please. Okay, there's the second half of slop 7. So quite a few questions, but there are 4 different equations which you need to practice, and all 4 of these equations are covered on these couple of pages. Okay, pause and have a go. Thank you so much for doing that. Our next lesson, and actually it's the final lesson of the electricity topic, is lesson 9 on the national grid. So between now and then, thank you for working hard. Do some retrieval practice of the lessons that you've been doing this week and today's lesson. Complete the slop activities and attach to each lesson as you do the lesson. Don't just watch the video. Please do take notes and complete the practice activities as well. And your recall test will happen either on Thursday or Friday. Look out for it. And don't forget to tell your friends about where to find this resource if any of them still haven't cottoned on to it yet. So, thank you for working hard. Thank you for all the effort that you're putting in with your learning. See you soon, and goodbye. Goodbye.